Right. Let's do this starter problem. And again, this is very similar to the kind of problem that'll be on the exam for this unit. This is a classic problem where a bullet goes through a block, and the bullet comes out going 100 meters per second. Well, it goes into the block going 400 meters per second, but it comes out of the block only going 100 meters per second. So it was slowed down quite a bit. So we want to know what is the final velocity of this block if it started from rest, just after the collision. And then also we want to know how much mechanical energy was lost during this collision. So let's do part A. Anytime you have a collision, please start the problem like this. The initial momentum will equal the final momentum. This is true for all collisions, all explosions, any interaction between two objects. If this is your isolated system, yeah, there are forces involved, and yes, the bullet gets its momentum changed, but the block also gets its momentum changed. And since we're going to consider gravity negligible, we're not going to worry about anything like that, we're going to say that the momentum is conserved. So what is the initial momentum? Well, it's all in the bullet. And then what is the final momentum? Well, it's in the bullet and the block. And it's that simple. Now, what are we solving for? We're solving for the final velocity of the block, and we know everything else. Everything is given. So we just use our awesome algebra skills to say V2 final. All in one step, well, we're going to go M1 times V1 initial minus V1 final. You see what I did? I subtracted this to the other side, and then I factored out the mass. And then now to get this by itself, I have to divide by the mass. So be able to do algebra that quickly. It's very handy. So M1 is 0.010 kilograms. And then V1 initial is 400 meters per second. Minus V1 final, which was 100 meters per second. And then I'm going to divide by M2, which is 4.0 kilograms. So V2 final, when I plug all that in, well, that's 300. So 300 times 0.01 equals 3 divided by 4. And I got 0.75 meters per second. Did you get that? If you got that pretty easily, then that's good. Now, I'm kind of running out of room. I think just to keep this all on the same page, I'll do part B up here. There's room up here for it. Now, delta E. Well, that's E final minus E initial. So start off that simple. Don't jump right into the nitty-gritty. Go through the basic principles. Well, what is E final? Well, that's the kinetic energy of the bullet and the kinetic energy of the block. So that's going to be, so delta E is going to be equal to E final, which is 1/2 M1 V1 final squared, plus 1/2 M2 V2 final squared, but minus E initial. Now, initially, this doesn't have any energy, and this has all kinetic energy. And again, let's say this is moving so fast that gravity doesn't have time to lower its height or anything. We're not going to worry about gravitational potential energy. And so this is going to be 1/2 M1 V1 initial squared. So delta E is going to be equal to, well, I'm just going to combine these two. So it's going to be 1/2 m1, and then it's going to be v1 final squared minus v1 initial squared, plus 1/2 m2 v2 final squared. Now I'm ready to plug in my values. That's going to be 1/2 m1 is 0.010 kilograms. v1 final is 100 meters per second. I've got to square that, minus 400 meters per second, and I got to square that. Now, here's what you can't do. You can't go 100 minus 400 is negative 300 and then square that. It won't work. You have to square them separately and then take the difference. And then plus 1/2, and then what is m2? 0.01 kilo. Oh wait, no, it's 4 kilograms. And its final velocity is 0.75 meters per second squared. And this is almost negligible compared to this, but we'll include it anyway. So I'm going to go 100 squared and then minus 400 squared. And that gives me negative 150,000 times the mass and divided by 2. So this altogether is negative 750 joules. And then we're going to add to it this, so plus, then I'm going to close parentheses, 0.5 times 4 times 0.75 squared. And when you do all that, yeah, see, that hardly changed it at all. Delta E equals negative 7,000, or not 7,000, 700. Why did I do that? Okay. Erase that. 749, if I round off, joules. So I lost almost all my kinetic energy. There's very little of it left after this collision. But momentum was conserved. So this is an inelastic collision because we lost mechanical energy in this collision, but momentum always stays the same. Can you do this on a test? Can you do this problem without, try this problem again later on. Give it a day or two. Try to solve it again without looking at the solution. If you can do it independently and you understand everything about it, well, then you're in good shape, at least for this problem on the test. That is all.